Hi everybody, this is Michael with Micronova. What I have below us here is a project that we made for Oakland University.
Yeah, hey everybody, how's it going? My name is Jason Gorski, founder and president of Micronova, designers and manufacturers of the AmpliPro home audio system. So today I'm showing off a really cool progressive build demonstration of how the AmpliPro home house audio controller is designed and manufactured. We created this progressive build as part of a partnership with Oakland University through an NSF grant to teach high school students how to design and manufacture electronic components. So as a really cool example for them to understand the process, we took the AmpliPro home audio controller and we broke it out into all the steps we took from our initial prototype that we built in-house all the way to the fully commercialized, assembled, manufactured, tested unit that we ship to our end customers. Today I'm going to walk you through all the different steps to build an AmpliPro.
Let's get into this cute project we made. Here we have prototyping and design. So the first thing you need is a prototype. What are we building? This is the layout of all the boards and all the things it does on an engineering level. This is the case and all of the whole locations and how the case is actually built. This is a picture of this prototype right here. And this is the CAD drawing of the final design. But you can see this prototype. We have like little jumpers on these boards. This goes to an LED board that's in here, but that's the prototype. This is the OG design of the AmpliPro.
This was the device we came up with many years ago and we built it in my basement. And this was just kind of us taking the tools we had at hand to put together an initial proof of concept of the system. So this is what we started with, and I'm going to kind of walk you through all the work we had to do as a company to get from our prototype design to the fully manufacturable, testable, quantifiable, commercial design that we sell now. First step was designing all the different printed circuit boards that are part of the device.
Here we have the LED board alongside a breadboard that has the exact same design and setup. It's just made with wires instead of the circuit board wires, basically, that are just hard in here. This is a little Arduino that's controlling both of these, doing the exact same thing. This is the back of the LED board. That's the same chip, just the sort of surface mounting, and that other chip is for a breadboard. So this is the front and back. These are the layouts of the boards. You can see on this layout the wires inside the circuit board, and then this is the engineering drawing that kind of describes everything that it does. For me, it's a little over my head. It all looks like license plate to me, but I just turned the screwdriver and put it together.
After that, we had to essentially figure out how to manufacture the PCBs with all the components on them. So this step is walking you through all the different pieces that are on each one of the boards. So for example, the heart of the system, the control board, is shown here. We have an array of different passive components. So we have all the resistors, all the capacitors, and then we have all the active components, all the different ICs that do everything from power filtering to digital and analog muxing and conversion. So we have our DACs, we have our ADCs, we have our network communication. So when you plug in the network cord, it can talk to our processor on our system.
So this is everything that goes on the circuit board laid out in a nice fashion here. You can see here, this is a reel of tiny resistors that the machine picks it up and plops it into place on something called solder paste. So this is basically like a silk screen, except it's metal, not silk. And the solder paste runs over it and deposits on the little gold contacts an amount of solder. So you then place the resistors and circuits on there and heat it in the oven so it melts the solder, and that's how you have a circuit board. So this shows a surface mount machine with a little solder squeegee. We have the layout of the control board. If you get real close here, you can see all these wires going to and from the different contacts on the control board. And then this is the engineering layout of the control board, the schematic, which that's just crazy to me.
After the assembly, we come to the final assembly of the system. So once you have all your circuit boards designed, you have all your components placed on top of your circuit boards, now you have to connect all those circuit boards together, you have to power them, you have to cool them, and you have to fit them in a case that's easy to transport and easy for the end user to install. That's where the final assembly step comes in. What's kind of cool about this box is it shows you literally everything that's inside of an AmpliPro unit. So here we have all the individual circuit boards, there's 7 of them. We have all the screws, we have the fan, we have the heat sink.
The Raspberry Pi, the power supply, all the cables that we put together. This is everything that goes into building an AmpliPro.
It's over 1,000 different pieces. Everything that goes into the assembly of a finalized AmpliPro unit, we're showing here kind of in an exploded view in this box.
Up here, we just have pictures of, all right, we grab everything from inventory, we use these tools to assemble it, and this is the AmpliPro mid-assembly.
Then the next step after final assembly is very important. It's quality control. Every single unit that you buy from us at Micronova is hand tested by our engineering and technical team here in Michigan. This kind of outlines a few of the different issues we see during manufacturing that our techs correct and essentially are on the lookout for.
I have 6 preamp boards here that all have an error on them. So if you look up here, these are some common surface mount errors: a lifted pin, a tombstone. This is when resistor or capacitor isn't all the way soldered down. They call it a tombstone. And then a bridge. You can see here it's connected to shorts. And then under here are the answers of which board's on here and where those errors are. We have a little magnifying glass down here that you can use to find the errors on the boards. And then over here we have a cable tester. You turn this on, you can see this cable is not working right because these 2 don't light up. We can swap it out for a different cable, and that's a good cable. So you can kind of see this is a go, no-go gauge, basically.
So these are just some of the design flaws that can occur during manufacturing that we're essentially checking for as part of our quality inspection. Along with this, we're looking for long-term problems as well, right? We're making sure once the soldering process has been completed that all the flux is cleaned off the boards, because over time they can cause corrosion of the boards. And these units are built to last, be a part of your home for many, many years to come. So it's really important that we're not only, finding areas of defects on the board that can cause initial problems, but we're also looking for areas that could cause defects over time. Probably the most involved process in the entire manufacturing step is the quality control. So after quality control, we come to the final build and packaging. And this is something that's really interesting for any type of electronic device that you're selling commercially. It's not only important that your product is of high quality, but your packaging needs to be as well. We're shipping AmpliPro units all around the world, and it's important that they arrive in good shape. So as part of that, our engineering team had to design the packaging for the AmpliPro system.
This is a box. It has a blueprint. And then this is foam for holding the AmpliPro inside of the box safely. We've done a little cutaway. So you can see what the final assembly with a plexiglass cover looks like.
Remember, the AmpliPro is more than just a unit. It's a complete audio system for your house. So it comes with all the cables that connect it to your home networking system, as well as plug it into your power, and then all the different connectors for connecting it to all the speakers throughout your house. We also include all the tools you need to actually install this unit in your house. So we include the screwdriver for making your cable connections to all your speakers, etc. So the final step in the manufacturing and commercial design process to go from the initial prototype all the way to a commercial unit that's ready to ship is this final packaging and this final building. So this is kind of a nice demonstration of everything that it takes to go from what our engineers initially conceived as a really cool prototype for a whole house audio system to a commercialized product that's built, assembled, tested, and packaged for shipping for our end users. So thanks so much for checking us out.
that is all 6 stages of building an AmpliPro. Thanks, guys.